We are going to continue with what we left off yesterday, but before that, a couple of announcements. If you haven't completed the pre-training survey or pre-test survey, it will be posted in the chat area. Please take a few moments and then complete that. Also, attendance sheet will be posted. You want to also complete that. And then I think there will also be a course evaluation form. We want you to, again, take a few moments to complete that. So your feedback helps us to develop and then design the program in a more efficient way. So we need that feedback from you. Take a moment and then complete the evaluation term. So without wasting any further time, yesterday, Dr. Nwafu gave us an excellent presentation on data preparation, evaluation, and visualization. So we are going to continue with that. Ibel, it's all yours.
Thank you very much, John. Good morning, everyone. So we're just going to jump right back into our conversation. Yesterday, we started the discussion on the basic premise of Pandas library. Pandas is pretty much a data or library that allows us to analyze data in Python. So you could think of it more or less kind of like your typical, you could say your SPSS data, but it allows us to bring in or import our data in the tabular form that we typically have in our Excel sheet or SAS or Stata. And then with the power of Python, we're able to do some interesting analysis on our data. So pretty much everything you can do in SPSS or SAS, you can do it using the Pandas library and Python. So, so yesterday we started off on that discussion and we looked at a couple of things, how to import our data, how to do some basic analysis, like looking at the number of columns. And today we're just continuing that conversation. And as time permits, we will move on to visualizing data using Python. So let's get started. Okay. So I believe yesterday we stopped we looked at null values and we looked at replacing null values. And I want to say the last thing we looked at is probably somewhere computing date and time. So basically we have a data set, and what we want to do is we want to convert the data type from a string to a time. And you might ask, why do we need to do this? This allows us to easily manipulate the time without having to deal with strings. So you could think of this more or less like casting. So the idea is you're converting from one data type to another. And in this case, we're converting from a string data type to a date type. And when we do this, the idea is that now we have the columns properly represented in the date data type. So as you can see here, the start column is now, as opposed to an object, it's now a date time data type. Also, the stop column right here, as opposed to an object, is now a date time data type. So with this, we can basically convert the time. We can extract just the days. We can extract the seconds. We can subtract the two, the start and the stop, to get the time difference between the two. So it allows more flexibility in terms of manipulating the data from the two columns. So that's one reason why we need to convert from the object data type to a date time data type. So here we are basically, once we've done that conversion, we convert the start and the stop time in the encounters DF. So encounters DF is a data set containing patient encounters. So what that means is you have patients who visit the hospital for different things, maybe emergency or just a regular checkup. So this is kind of like a fictitious data that they collect for those kinds of encounters. So we're just trying to get the start time, which is the time they get into the hospital, and the stop time is the time they leave the hospital. So, so here we're doing basic manipulation on the date. We're trying to get the difference between the two. So basically seeing how many like you could see how many hours, how many minutes, how many seconds, how many days they stayed in the hospital. In this instance, we are getting the difference between the stop and the start column, and we're converting that into the days. So we want to see how many days each patient stayed in the hospital, and then we're sorting that. So you can basically, once you do this, it will return a number of rows basically that allows us to see the number of days that each patient in this table have stayed in the hospital. So the result is returned. Again, the way Pandas works is you have to save the result into a variable in order for you to use it. If you do not do that, it's just going to return the values to the console, as opposed to you being able to use this in a different as part of your code. So if you want to do that, you would have to save this as maybe another variable as number of days, and that will allow you to be able to reference the same, all of the values you see in here. So basically, that's what we're doing here. We're creating a new column. So instead of just saving it as a variable and then we can use that, we can include the resultant values that are generated from the computation over here, which is checking for the number of days that each patient has stayed. We can include that as part of the table. So how do we do this? It's by basically creating a new column in the data frame and assigning the values of the result to that new column. So here we have encounters DF, which is the data frame that stores the encounters table, and we are creating a new column in that data frame. So we call that new column duration of stay. And then we assign that new column to the resultant value generated from the difference for each row contained in the table for the stop column minus the start column. And we are only interested in the days and not like the hours or minutes. So we just only are interested in the number of days. So basically, the start and the stop time can be converted into days, it can be converted into minutes, it can be converted into seconds. But in this case, we say we want the number of days and not the number of hours or minutes or seconds. So now when we view the data frame, which is the table, the encounters table, we notice that this duration of stay is part of it now. So at the end of the table, we have a new column. Originally, this was not part of the encounters table, but now because we've created that here, we now have this new column called the duration of stay. So it's pretty straightforward to create new columns in the table. All you need to do is to basically have a format such that you have the data frame, and then you have some brackets, and then the name of the column you want to create. And then you could assign it, depending on what you're trying to achieve, you can assign it to a resultant value. And when you run this, it should create a new column for you. So you can always add columns, you could delete columns as well. Okay, that reminds me, I believe somebody asked a question yesterday about the how you can basically manipulate or get like subset of values using like the indexes. Let me go over that a little bit for a little second now. So let's use the encounters df. Let me see if this still runs. Okay, I think I might have to do. Okay, so. All right, so one thing that you might realize is every time you close out this out, or you will need to rerun some of the components. Like it's saying that I don't have the pandas column loaded. So I have to rerun that before I can execute the portion at the bottom. So if you get an error saying, oh, pandas is not recognized, then that's what the problem is. You might have to go to the top to rerun. Cynthia data is not defined, so I think it's defined somewhere in the top, so I'm just going to look for that. Okay, there we go. Run that and then go back to the, okay. Right, so I'm just going to go directly. You can skip out from running some of these because the way Jupyter Notebook is structured, it's a column-based execution format. So so you don't necessarily have to run everything. You can skip out of some columns depending on what you're trying to do. So here, this just displays the first 5 rows. So we don't need to do that now. We're just interested in the slicing of the data set. So so let's do this. So say, for example, we have this data frame and we just want we want to get like the first 5 rows, or we want to get the first 20 rows. We can use what is known as the ilock. So this function allows us to basically manipulate the data frame such that we can get like number of rows, we can get number of columns, and so forth. So basically, the way it works is you can specify slicing based on the row, you can specify slicing based on the column. What I mean by slicing, I just mean getting like certain subset of the data. So I could say, give me the first 5. I could say, give me the first 5, and that returns the first 5. So the way it works is using ilock, the 5th, the stop column is not inclusive. So you notice here, it includes the 0 and it stops at 4. The stop index is not inclusive. This is more or less like a Python thing. When you do a string or you do list slicing, it doesn't include the stop column, the stop index rather, but it includes the start and it stops at n-1. So it also happens here. Also, say, for example, I want just the first 5. I want the first 5 columns. I could also do that here by saying just the first 5 columns. So now, I know this is a little confusing. what this is doing here is I'm saying, give me the first 5 rows, and also then separated by a comma, give me the first 5 columns. So so basically you can use the iloc to filter your data such that you can get X amount of rows and X amount of columns. You could also say, I'm not interested in the first 5 rows. I'm only interested in the first 5 columns. Let me see, since this, you need to do put the semicolon, which just signifies that you want to get all of the columns, you want to get all of the rows rather. And then this signifies that you just want the first 5 columns. You could also say this as well, but you don't, if it starts from 0 index, you don't necessarily need to include the zero, the first index. So basically what this says is, hey, I want all of the rows, and then I want just the first 5 columns in the data frame. You could also say maybe the first 2 columns, either way. But the idea here is you can filter the data such that you can get X amount of columns, X amount of rows, and so forth. So say you're not interested in all of the data, you're just interested in the first 10 or the first 50, the first 100. You can use this iloc functionality to filter your data set such that you can do that. Again, remember, this only returns to the console. If you want to save it, you can create another data frame, a variable to save it. So you call the variable filter df, and then it saves that the result to this new, the result of the subset data frame to this new variable. So hopefully this answers that question about how you can maybe manipulate the data frame to get subsets of the data frame. Okay, so I believe last class we also talked about the describe. So just real quick, when we use the describe functionality, what that does is it basically gives us summary statistics of the data frame for each column, gives us the count, the mean, max, standard deviation, all of the percentiles, 25th, 50, 75th percentile, and so forth. This can be used if you just want a quick summary statistics of your data set. You could also use this for categorical values to get like the count of the categories and get like which of the categories have the largest amount of count. So in this case, we are only looking at the encounters class column, which just tells us, if you look back at the data frame, the encounters class tells us what type of visit. Is it a emergency visit? Is it a wellness visit? And so forth. And when we do a describe, excuse me, where are we? When we do a describe, when we call the describe function on this column, it gives us the total count of the column, gives us the number of unique categories associated with that column, gives us the top contender in the column. So what this means is the wellness category has the most amount of visits. So you can tell that a lot of people visited the, in this data, visited based on a wellness visit. And also it gives us the frequency of that wellness visit, which is 19,106 visits. You could also, if you're interested in looking at the specific frequency count for each category, you could do use the value counts function. And what that does is it gives you a breakdown for a categorical column. So in this case, we have 19,106 visits for wellness, 18,936 for ambulatory, and so forth. So this way, we're able to give like a frequency breakdown for each category. So I believe we talked about this, so I'm going to scroll, just skip past them last class. Okay, so let's get started with conditional statements or conditional, conditional statements. So in every programming language, there is some notion of condition. So you have conditional expression. If this is greater than this, you can do this. Or if the values or the scores are greater than 50, maybe you get a D or so. But the notion of conditions are well represented in programming languages. So we can also use that that conditional syntax in Pandas. So we can filter values based on certain conditions. So an example here is we can filter values based on the gender of a specific patient. So here we're saying if the patient, so patient's DF is one of the data frames that we created earlier. I'm just going to move through to that data frame. Okay, so this is patient's DF. We did this last class. It contains information about the patients. So going back to the example using conditions, you can get basically you can filter the data based on all of the based on the gender. Maybe you're interested in seeing what all of the categories that have gender as female looks like. You can perform that filtering using some kind of Boolean condition. And Boolean condition is not something that is new. It's something that has been implemented or has a lot of use cases in programming languages. So say, for example, we are to filter based on the gender. We only want to see patients who identify as female. So we can basically set that condition by saying, get me all of the patients that identify as female, because in the gender column that contains the gender of each patient, and we know that that gender can either be I think it's identified as F and M. So so we can say that we only want to fetch the column in which the patient's DF is equal to F. And what this is a conditional operator, and it just means equality. So it's saying that this the result here should be, if the result here is equal to this, then it's true. If not, it's false. So if you run this, for all of the columns, it's only going to return the Boolean values of the gender. So what this means is the first row is not female, so it identifies as male, or whatever the case is, whatever gender that is. So here we have this is false, which says this is not female. And then where it says true, that means that it's female. So we can use this Boolean condition to filter our data such that we are able to filter the data frame to only return the records that have the value of F as their gender. So how do we do that? It's pretty simple and quite interesting. So we have a data frame. The data frame is patients_DF, but what we're doing is we're passing in the condition that says patients_DF gender equal F. So what that means is filter the data such that I only want to get the ones that in which the gender is F, which in our case, it just means that that is female. So if you run this, what you're only going to get is, if you look at where the gender column is in the result that is returned by executing that code, you would see that it only has the ones with female on there. Let me see, is the gender here? So I guess it truncates that gender, but the only result that is returned is the date is a new data frame that only has the gender as female. Pretest, okay. All right, so please feel free to interrupt at any point in time if you have any questions, totally welcome.
Dr. Abel, I do have a question.
Yes,
So the two equal signs basically create the condition, the true or false condition, right?
Yeah, so it's a Boolean expression inside. So here it's saying that fetch me the if the gender column is equivalent to a female, return true. If the gender column is not equivalent to a female, which in this case we indicate by saying F as female, M as male. If it's not equal to F, then return false. So it returns the column, the Boolean values of the column. Here, the first row identifies as not female. That's why we have the false here. Also here as well. The third row is a female, so it returns true. So this is more like a Boolean expression. And we use this, this expression to filter the data frame. So we're interested in the records that identify as female. So that's why we can use this condition to further filter the data frame, that we only fetch a new data frame that for all of the patients that identify as female.
Yeah, I have a follow-up question.
Yeah.
Is the Boolean variable a type of data in Python, or is actually a 0 and 1 like in R?
You said, is it a type of data?
Right,
So,
type of data, a data type.
Yeah, yes. Yeah, so yeah.
It's not actually a 0 and 1, right? Because like
No.
in R, they actually, you create it actually at 0 and 1.
No, so the Boolean, it returns false or true. So the false and true are it's a type. So Boolean is a type in Python. Hence why you see the false and the true. So this is like a specific type, yeah.
Okay, so like say if we use it, we can treat it as a 0 and 1 data.
No,
Okay.
no. You would have to basically convert to say false is 0, true is 1.
To the one we
But-
use. Okay, got it.
Yeah. Mhm. All right. So now we're able to filter the data such that we only return the number of patients that identify as female. And we can use this not just only for obviously not just for filtering number of patients that identify as female. We can do this using more complex conditional statements in our filtering. So this is basically just saving that result into a new variable. We call this variable female_df. And we can get the shape. Remember when we talked about shape, it just means the dimension of the data frame. So here we're looking at the dimension of the original data frame, and then we're looking at the dimension of the new data frame that only contains the patients that identify as female. You can notice that it's significantly less, slightly over, I want to say half of it. But yeah, you can see the size of the dimensions of the data frame for the original and the new data frame. Okay, so you can also perform complex conditions, and not just only the equality operator can be used. You can use the greater than, the less than, all kinds of conditional statements you can execute using that same logic. So here what we want to do is we want to select all of the admissions where the duration of stay is more than 1 day. So remember, we've calculated a new column called the duration of stay. So all we want to do is to check if that number is greater than 1. And we filter the results based on that condition. So this is what the code looks like. We have the encounters DF table. Again, we're jumping back and forth from different data frame, which is okay. But one thing to note is this is different from the patient's DF. The encounters DF contains information about the patient's encounter. So the type of stay, the length of stay, the start time, the end time, and so forth. So here, what we want to see is how many patients stayed more than 1 day. So here we have the data frame encounters DF, and then we have our brackets. Then inside of that, we have our conditional statement. So here we have the encounters DF duration of stay column. So what this does, it only says, fetch me that column that contains the duration of stay, and then compare the results to see if it's greater than 1. So what does this condition mean? It means that if the duration of stay column is greater than 1, you return that as true. And then at the entire data frame, we only want to see the result that are returned as true, which means the duration of stay is greater than 1. So just taking out the head portion and running this, let's see, I think it says key error duration of stay. See if I have it wrong. Okay, so I think okay, let me see, make sure I have the duration. Okay, I do not have the duration of stay in there. I need to run the portion. So again, you make sure you run, I think the best thing to do for starters might be to just run everything from start, because if you don't follow the lines, you might skip a part, and then you need that part at the later part. So I am going to run the portion that says duration of stay. So here, run this, also run this one, I believe, no, this one here. Then duration of stay, okay, and all right. Okay, now I do have the duration of stay column included. So now I could run that again. So remember, the duration of stay column was a new column that we introduced. Make sure you run the previous code so you can include that column as well. All right, so now when I run that conditional statement, you notice that the condition says if the duration of stay is greater than 1. So now we can see that result. The result is returned. It returns a new data frame in which the duration of stay is greater than 1. We could also we could look at the dimensions of that data frame, which just says that it's 344 rows and 16 column, as opposed to the original data frame, which is 53,346 rows and 16 columns. So not quite a lot of people stayed more than a day. We could also look at more of a categorical data to see which person stayed over 1 day for each category of emergency or of each category of visit. So how do we do this? We can save this as in a new variable. So we can say encounters DF, I guess you could say days, and then we can save that in a new variable. And now we can use this new data frame, and we can check the value counts for that data frame. So here it says 183 people spent time greater than 1 day for the ambulatory category, 115 for outpatient, 45 for inpatient, and then 1 person spent over 1 day in the emergency room. So we can basically perform multiple types of condition or filtering using the notion of the Boolean expression. So by using the greater than, less than, equal to, we can filter our data based on certain categories. All right, so going into more complex or more complicated Boolean expression, we can perform multiple conditional statements using the and or statement. So we can combine, we can combine multiple conditions using this, the or and statement. So what we've seen earlier is just one Boolean expression. We can have multiple Boolean expressions combined together. And how do we do this is by either using the or, the and statement in our condition. So let's look at an example here. So the question is, let's filter the encounters data frame to show only the urgent care and the emergency care encounters. So we're only interested in the urgent care and emergency care. We don't want to see the ambulance or the inpatient or the outpatient. We only want to see all of the patients that have the urgent care or the emergency visit, or have had urgent care emergency visit. So we can create a Boolean condition. If y'all can see the condition here, what this is saying is we have multiple conditions inside. The first condition is saying, fetch me the patients in which the encounter class. So remember, the encounter class is the column that contains the type of visit. If it's an emergency, if it's a outpatient or inpatient. So what this is saying is fetch me the column in which the encounter class is of type emergency. And then you notice this really interesting character. What this means is or. So the sign for or is using the one line here. The logical operator or in this instance is using the one line. This is slightly different from the typical, the type of or you would use in say Python or say, you typically can say or, the keyword or and, but here we use the one, I'm not sure what character this is called, but we use this to represent the or Boolean expression or conditional state expression. So it's saying fetch me the number of patients that the type is equal to emergency, or also fetch me the number of patients in which the encounter class is equal to urgent care. So this Boolean expression only evaluates to true if the two conditions are met. So if that patient either has type emergency, or if that patient either has type urgent care. So if it's none of the above, it returns false. So basically this returns just a column with true, false for each record in the encounters DF table. And now we can use this Boolean condition to filter our encounters DF table, because we already have these complex Boolean condition, and now we can pass that to our encounters DF table. And what this does, it returns a new data frame that consists of only the conditions that evaluate to true based on this Boolean expression, where the encounters DF encounter class column is equal to emergency, or the encounters DF encounter class column is equal to the urgent care. So here, this is where we actually filter the encounters DF data frame to return the results. So let's go ahead and run this as well, and then run the encounters DF condition. So we put the dot head here just to give us the first 5 of it. So basically, the result that is returned here is the condition that is a new data frame that satisfies the condition where the encounter class column is equal to the emergency visit, or the encounter class column is equal to urgent care. So if you look closely at the result, let me take out this dot head. So if you look closely here at the encounter class column, you notice it's only urgent care and emergency that is allowed. Let me ask a little trick question here. What if we change this to an and? What, just right out the bat, what would be the result for that, if we are to run this and then we run the encounters? No, yes, that's correct. So it shouldn't give us a result. Obviously, it's pretty much either or, because you typically go into the hospital for one or the other. Well, maybe not, it depends, but just looking at the data, we only have one value per record. So it's either you're an emergency category or you're urgent care. So if you should change this, what this means is give me the result for a patient who is identified as emergency visit and urgent care, which I don't believe there is that there's any patient with both categories. It's either one or the other. So let's just go ahead and run it just for, all right, so run this and it gives us blank. Basically, it just runs all of the columns, but doesn't give us any result. That's because there isn't any patient that has either emergency visit and urgent care. So basically, you can do all kinds of fancy, complex Boolean conditional statements by using this type of logic. And you can use this to filter your data. So you might have interesting questions in your data set. You want to look at patients who are over 50 years and also visited the emergency room. You can use these types of Boolean logic to further filter your data. All right, so more on that. So I guess this is just getting the dimension of the condition here. So this was the one we just ran earlier. All right. So more on the filtering, we can have complex conditions, like I said earlier. Here we have the duration of stay is greater than 7 days. Total claim cost is greater than 1,000, and the encounter type is emergency. It's pretty much the same concept from the last time. We put in the condition, encounters DF duration of stay is greater than or equal to 7, and encounters DF total claim cost. So now we're looking at specific columns, because remember, the columns represent specific data. So duration of stay is a column, and total claim cost is a column, and encounter type is a column in the encounters DF table. So we can combine the Boolean expressions, and then we can filter our data frame using the combination of Boolean expression. So in this case, what we're doing is we're satisfying these conditions using the Boolean expression here. And when we run this, we should get a new data frame, because we saved that data frame in a new variable. we should get a new data frame called result D_df that contains these conditions, where the duration of stay is greater than 7 days and the total claim cost is greater than 1,000 and the encounter type is emergency. Well, actually, there is a slight error here. Can someone identify what the error in our result is? This is what we're supposed to satisfy. Can someone identify what the error? Let me see. $100 costs. Yep, that is one error. What else? Inpatient. Yes, correct. So it's 1,000. It should be greater than 1,000 because the condition says we only want to filter that. And also, as opposed to inpatient, we need to check for emergency and not inpatient. Okay, seems like we don't have anyone that meets that condition from what we're seeing here, because it returns null. It returns null. So I don't think there's any patient that meets this condition, emergency. Just make sure that I have everything. Yes. And 1,000 and greater than stay is greater than 7. Duration of stay is greater than 7. I'm just going to say greater than 7 in this. Yeah, there is no patient that meets that. But the idea is you can have complex Boolean expressions based on certain conditions. All right. This one. Okay, so another thing that we need to talk about before we move on to visualizing data is the is what we call aggregating data. So say, for example, we have our data set. Sometimes we want to group based on certain categories. So you want to group based on the total number of the encounter class. So we want to group based on number of patients by the emergency class, or number of patients by the encounter class. Certain times we require some form of aggregation, maybe summation or min-max. So how do we accomplish that using Pandas data frame? I'm pretty sure at some point we've probably done aggregation in our respective analysis. Maybe it's calculating the sum or it's grouping data. Pandas does allow us to do those kinds of aggregation functions as well on our data frame. So the tables are referred to as data frame. I don't think I implicitly mentioned this, or I explicitly mentioned this. When I refer to data frame, what I mean is just those tables that are represented in the Pandas library. Okay, so there are so many aggregation functions, and they perform different tasks. We can calculate the total number of items using the count function. We can calculate the first and the last item in the data frame. We can calculate the mean, the median of a specific column. Obviously, you're not calculating the mean median of the entire data set. You're calculating the mean median of a specific column. And then you could also do min-max, standard deviation, and variance. You could do a min absolute deviation. So many things that you can, or aggregation functions, as you will in other analysis tools you can use in Pandas. So let's look at an example of how this can be done. We want to find the mean duration of stay. So what is the average length of stay in the data set? So here we get the encounters DF table, and we only fetch the duration of stay column, and then we call the mean function. This should return the average duration of stay in the entire data frame or the data set, which in our case is 21.84. You could also count the number of patients or the number of records that have a duration of stay, which this does not include the null values, by the way. So when we run that, that's 53,346 records. We could also calculate the mean duration, the minimum duration of stay, which just means the lowest, which is 0 days. And we can calculate the maximum duration, actually, let's do that. We can calculate the maximum duration of stay. What's the longest patient, the longest patient that stayed in the hospital? That's 31,920. Again, this might be a data error, it might be true, but this is what we're getting from our data set. And then we can calculate the sum as well of the duration of stay, which is it's about 1.16 or 1.17 or so million. So basically you can perform different types of aggregation functions on the data set. Again, you're performing this on specific columns and not the entire data set when you calculate the mean, standard deviation, and so forth. Likewise, you can perform groupings. So you can basically group by certain categories. In this instance, we can split we can do a group by to group the data based on the categorical data. Typical group by structure is as follows. So you basically have your categorical data, your categorical column, and then you have the data. You can split the data based on those categories. So we want the number of A's to be segmented, the number of B's to be split, and the number of C's to be split. And then we can calculate the sum based on the A's, based on the B's, and based on the C's. So this is a hypothetical example, but this is the typical structure of a group by command, where you split the data and then you combine the data. So here, another hypothetical example, it's kind of similar to what we just saw. We create a new data frame. We have our data frame contains a bunch of A's and a bunch of B's and C's. This is what our data frame looks like when we run that. So, and then what we want to do is we want to group by the sum of each component. So here we group by the key column, and then we aggregate the sum of the grouping. We don't necessarily have to do this. We can group by a key. Let me see. And then df group by key, and let's say sum. We could also do it this way. Instead of using the aggregate function, we could say the results from that, we can call the sum function, and it would basically give us the summation. Instead of using the np.sum. We could also group by and get only the first values as opposed to the sum. So if we're not interested in the sum of the grouping, we can just say group by the categories, which is the key. You can only group by categorical data. So in this case, the category is A, B, and C. We can group by that column because it has a category. And here we only want to return the first element for each group. So in this case, for A, it's 0, for B, it's 5, and for C, it's 10. So A equals 0 here is the first siding of A, the value 0, B, the first siding of B is 5, and C, the first siding is 10, right there. And you could do this with the last and so forth. But the idea is when you group, you're basically clustering by categorical data. So here, we're basically splitting off based on categories, and then we can perform different types of aggregation on the groups. It can be summation, it can be average, it can be mean, it can be maximum value, or whatever the case is. Okay, so this is more of a realistic example. We want to create a new data frame that contains the mean duration of stay for each encounter class in the admission table, or what we call the encounters table. So here we create this new data frame called group_df. And in this data frame, we have the encounter class column and the duration of stay column. And then we group by the encounter class. If we just want to, if we want the data sorted by key, which command should we use? That's a great question. So you can sort based on a, I believe it's a sort index. Let me see. I think it's somewhere in here. I want to say we've seen that before. So let me get back to you on the exact command to sort, but you can definitely use, I want to say it's sort index, but I'll have to get back to you on the exact command. Yeah, but you can sort based on the categories, like you said, yes. Okay, so where are we? All right, so here, so we're only returning the two columns, the encounter class and the duration of stay, and we're grouping by the encounter class column. And then we only want the mean values, not the total value of the sum. So when we run this, it gives us the encounter class and the duration of stay, but it only gives us the mean duration of stay and not the total duration of stay. If we wanted the total duration of stay, we can either use the count function here, and it gives us the like the number, or it gives us the sum. We can use the sum as well. Gives us the total duration of stay for each category. It's interesting to note that there is 0 in the wellness and urgent care. So it means that nobody, nobody stayed past, which kind of makes sense. If urgent care, typically it's kind of like really fast. So you're not expected to be there past like a couple of minutes or hours. And also wellness too as well. So these are not like, I guess, places where you're admitted into the hospital and so forth. So it kind of makes sense to have 0 days on them. But the idea is you can basically group by a category, and then you can perform some kind of aggregation on those categories. It can be either sum, it can be mean, it can be max, whatever the case is. Oh, yes. One other thing, we didn't talk about this reset index function. Like I said, there are a ton of functionalities when it comes to Pandas data frame, and we cannot cover everything, but we try to give you building blocks to build on top of that and to learn some more. There's a lot of resources at the end of this that can help you further build on some of the things that we've introduced here today. So the reset index, let me see if I could find that. Okay, so the reset index is basically a way of, like the name entails, resetting index. So sometimes you might do some computation or you might combine data frame and you need to just reset the index. So here, instead of having disjoint results, it just resets the index from 0 to n-1. That's what that is pretty much for. Okay, so we are going to skip to concatenation just because we have in-class exercise, and then we also need to cover the visualization portion somewhat today. All right, so let's talk about, say for example, you have two data sets and you want to combine them together. And say the data set, they're too large that you cannot manually copy and combine. Pandas does allow you to import the data sets and to programmatically combine them together. How do you do that? So one way of doing this is by using the concatenation. So the concatenation function, well, the concat, it's called concat. The concat function allows us to combine multiple data frames together. So when I say multiple data frames, I'm talking about data frames that are identical. So you're not combining apples and oranges. You're combining data frames that are the same columns. All you're doing is you're just attaching one to the end of the other. That's what the concatenation is for. If you are to combine multiple data frame with different types, there is another way of doing this. But with the concatenation, we're talking of data frame that pretty much are similar. Okay, so let's look at an example of what that would look like. So let's just assume that we have two data frames. So df1 and df2. You can see an example of what df1 looks like and also an example of what df2 looks like. Say we want to combine these two data frames together. How do we do that? It's pretty easy. You just say PD. Remember what PD is? That's the Pandas library that we imported to our program. So we say pd.concat and we pass in the two data frame as a list. So df1 and df2 is passed in as a list. And when we run this, so I think I need to run this first. Make df, no, okay. See, run this first and then run this. Then run this. Okay, so now when we do pd.concat and then we pass in the two data frame in a list, that gives us a new data frame. If you pay close attention to the new data frame, you notice it's a continuation of df1. So df1 has a1, b1, a2, b2, and then the new data frame that we created is a1, b1, a2, b2, and then continuation with df2, a3, b3, and a4, b4. So it literally defines the word concatenate, which is joining two things together. So this is good for data set that are identical, that you just want to combine one to another. So it's an extension of the other one. So we can do this not just only with two data frame, by the way. It can be like 5 data frames and you just want to concatenate all of them together. You could also perform this as well. So you can concatenate based on the rows. You can concatenate based on the columns. I know I did say it's joining two data frame, but you could also concatenate by column. So by default, you're concatenating by rows, like we've seen earlier here, where you're joining df1 and df2 together, but you can also concatenate using the columns. So in this example, we have df3 and df4, and we want to concatenate by column. So we want to merge them column-wise. We just specify here that we want the axis to be equal to 1. So 0 signifies row and 1 signifies column. You could also change this. You don't need to say that. You could change, I think it's columns. Yeah. So you can change this instead of saying 0, 1, because I know it can be confusing at times. So you can change this to axis equals columns or axis equals rows. And that way you know how you're concatenating. So here we're concatenating by columns in this instance. Wonder what happens if we concatenate by rows. It's basically going to try to join both of them together by rows, but you notice here it creates the 2 columns, and also you see a bunch of null values. This is because df3 does not have column C and D, and df4 does not have column A and B. So it tries as much as possible to merge the 2 data frame together, but it creates a bunch of null values for the ones that are missing, because these columns are not identical in the 2 data frames. Okay. All right, so just like you can concatenate, you could also do what we call a merge. A merge is similar to concatenation, but the idea with a merge is a lot more efficient. So instead of using concatenation, the merge is more memory efficient, but they have similar functionality, a slightly much more better outcome using the merge command and also using the join command. So let's look at what that looks like. So we have 2 examples, hypothetical data frames, df1 and df2, and we want to merge them together. So the way the merge works is kind of like the way SQL join works. So remember, for those of you who have experience with SQL, you know, when you're joining a table, you're joining a table on an identical column, based on an identical column. So either one column serves as the similar column that allows you to join the 2 tables. Likewise, when we come to merge, it kind of takes the same premise here. So we can merge by default. When you merge 2 columns or you merge 2 data frames together, it merges them on the identical column. So in this case, we're merging df1 and df2 together. It combines the 2 of them based on the identical column called employee. So when we run this code, it merges Bob based on it merges the 2 tables based on the identical column, which is employee. So Bob appears in df1 and Bob appears in df2, and the result in the new column that we create, df3, or the new data frame rather that we create, df3, as a result of the merge of df1 and df2, is Bob has the employee Bob has accountant as the group, and also the hire date as 2008. So right here, account. So what it tries to do is just merge on a commonality. So another example here is we're merging df3 and df4. This is what they look like, df3 and then df4. And we're merging them based on the commonality. In this case, it's called group. Group is the commonality. So by default, it tries to identify the commonality between the two tables and merge them. If we go back to concatenation, it doesn't do that. It just adds the columns. You notice here, A, B, C, D, it just joins all of that together. But the merge tries to kind of join them together based on some common ground that they share. And in this instance, by default, it looks for that common ground. You can also specify the commonality between the two of them, the two data frame, if it's not explicitly stated. You can identify that also as well. So going back to this example, we try to merge based on the commonality, which is the group. So when we run the merge, it basically returns a new table or new data frame with the combined, with the two combined data frame. You notice engineering appears twice. Let me see, Jake, engineering, Guido, and Lisa. So basically it repeats the values of the engineering from DF4, and you notice that is basically engineering, and supervisor is Guido, and then Lisa also is from the group engineering, and the supervisor is Guido. So basically that's the premise for a merge, using the merge function. It tries to combine based on some commonality. We're going to skip over some of this. Yes.
I have a question regarding the one-to-one join.
Okay.
Because the sorted is not required here, right?
Mm-hmm.
So how you determine the order, like employees? Like for example, if I want the order of DF2, should I just put the DF2 first and then DF1 later, and then just use the DF2 order?
So you could let me see first. So yes, it sorts based on the first to the second. So if you notice here, DF1 appears first before the DF2. But you can always sort based on a column if you want, though. You can at the end of the day, you can sort the table, the resultant table, based on a specific column. But the way it works, it sorts from the left to right.
Okay, got you.
Yeah,
so it's always the first, like say if you say display, or if the concat DF2 and then DF1, and that will be based on the DF2 order.
Sorry, can you repeat that again?
So is that just depends on when you do the concat, and then you put the one in the first, that will be the one.
Yeah, yes.
As the key, right? As the key.
Yes. Yeah. So it sorts by left to right, it joins by left to right, it concats by left to right by default. So if you look at this example, yeah. But again, you could always order however you choose at the end. If you decide, you can sort by maybe groups, or you can sort by but by default it sorts, it joins by left to right. Yeah.
Gotcha. Thanks.
Mm-hmm. Where are we? Okay, so again, this is just kind of showing you can do a one-to-one merge based on commonality. You can do a one-to-many and a many-to-many, which is pretty much the same idea as well. It's joining based on some commonality. So let's look at another interesting portion of the merge, which is, say, for example, you want to specify what the commonality is. You can specify that by using the on keyword. So there might be certain instances where you explicitly want to specify what the commonality between the two columns are. You can do that by using the on keyword. So in this example, we have DF1 and DF2, and then we merge the DF1 and DF2, and then we specify what the commonality between the two tables are by using the on keyword. So here, we're basically doing the same thing. We don't necessarily have to do this, in this case because the default is going to work, I believe. Yeah, but we could also specify using the on keyword what the commonality is. Just as we can specify the commonality, sometimes the tables might have a common column, but they're not named the same, because the only way the default works is if you have similar columns. So in this example, a group is common between the two, so it takes that as the commonality. But there might be some instances where you don't have the same column name. So in this example, df1 and df3 have no commonality. Well, they do have commonality, but they don't have a common name. So the commonality here is the employee name, but it's labeled employee in df1 and labeled name in df2. We can, however, still join these tables together or these data frame together, but instead of just using the default, we need to specify what those names are. And that's where we use the left on keyword and the right on keyword. So here we say, merge the two tables together or the two data frames together, and then the left name is employee and the right name is name. So this way we're able to merge them regardless of the naming convention between the two tables. One thing I would say, the two tables have to still have a common column though. They might just be named differently. So you can try to merge apples and oranges. They have a common column, they're just named differently. Okay, so so again, like I said, the merge is more expressive in the way we can do the types of merge. Remember, if y'all have done some SQL joins, you know that when it comes to joining, you have what we call the inner join, you have the left join, you have the right join. You can also perform that also using the merge as well. You can specify what type of merge that is. If it's an inner merge, which means the intersection between the two tables, or it's a left merge or right merge. So here we have two data frames, and what we want to do is we want to get the merge. By default, it tries to merge the intersection. So what that means is the commonality between the two data frames. So here we say merge df6 and df7. That will only return the commonality between the two. So Mary appears in the two data frames, so it only returns that value Mary. If we want to just combine this, we probably want to use like maybe concatenation or a join. But when we say merge, it specifies what type of merge. We have to specify what type of merge that is. So this is what we call an inner merge by default. How do we specify what type of merge that is? We use the keyword how. By default, it's an inner merge. So what we just saw earlier here is what we call an inner merge. It's the intersection between the two data frames. We could also specify if we want an outer merge or left or right merge. So outer merge just means merge the entire data frame, regardless of if it's a commonality or not. A left merge means merge the left data frame in combination with the right. So let's look at what a left merge will look like. So we have these two data frames, df6 and df7, and we want to do a left merge. So you can see here that the left merge includes the left data frame and only includes the intersection of the right data frame. So here we have Peter, fish, and then we have drink. In this, there is no recollection of Peter. There's no commonality between Peter and the right data frame. So we have the null value for that. And then we have Peter, beans, and then there is no commonality or there's no reference of Peter in the right data frame, we have a null value. And then we have the Mary and Brad. There is a commonality between the left or right. For that, we have Mary referenced in the right data frame. So we include the drink, which is wine. But you notice it favors the left data frame in the left join. It includes everything in the left data frame, but only the intersection in the right data frame. Likewise, the right merge also does the same, which is the opposite, includes everything in the right, but only the intersection in the left data frame. So this way you can basically combine multiple tables together. You can either do that using the concatenation, or you can do that using a merge statement. Merge is more expressive in the way you combine. It basically represents intersection or union between two data frames. But the concatenation, on the other hand, is just kind of, it creates a way for us to either concatenate based on the rows or concatenate based on the column. Okay, so I think for right now we are done with this. Let's do this. Let's switch over to before we do that, we're going to take a break in a sec, but I do want us to talk about what we're going to do next before we move to a break. Let's take a look at the exercise. So once we get back from our break, I want us to take some time to look at this exercise. And I want each and every one of you to try to attempt this exercise. And then once we come back from the break, maybe we'll take another 20 minutes and then we'll go over this together as the entire class. All right, so let's take about 10 minutes and return around 12:36.
You want us to do this during the break, or you're going to look at it when we get back?
No, we'll look at it. We'll start it off after. Sorry. Yeah. Maybe
Okay,
I
thank
wasn't
you.
quite clear. Yeah, we'll start
you.
it off after the break, but you can take a look at it if you want during the break, but we will take some time off to start this after the break. All right. See y'all at 12:36.
And hello, as you wait, please check the chat area, and then if you haven't completed the pre-test survey and then the attendance, please take your time and then do so. And also there will be evaluation posted. Also take a moment to complete the evaluation. Thank you.
hello, Ibrahim.
Yeah.
So so there's one Mary Ita Morris. She is on Slack, and she says she's. Oh, okay. She's in the class now. Okay, cool. Thanks.
Dr. Emily, can I ask you a question?
Yeah, sure.
Yeah, when you make a data frame, you put A, B together, but when you spell it out, it's showing A, B column, but in the dictionary, in the data frame, you put A, B, then.
Which one are you referring to?
Previous one. Okay.
Oh, is it, let me pull that up.
Margin.
Okay.
before merging. Yeah. Mhm. I know you put the dictionary as, yeah, go this one, yeah.
This one?
Yeah, I
Oh.
saw yes. So AB, yeah. See the
Mhm.
AB together, but when you spell it's coming in the frame AB separate.
Oh, I see what you're saying. Oh no, this is don't worry about this. This is talking about
I know,
we
but
have a function that creates this. So the function is somewhere here. Make df. So yeah, this is more for us to visualize our data frame. So we're actually doing this using a function. We're not doing this using a dictionary. So it's kind of a way for us to easily see this on here.
separate, yeah.
Yeah. It's not, this is a custom function that we
Custom
wrote.
function.
to,
Yeah, okay, that's
to
why, because I saw it's
visualize.
AB, it's not a one variable. It
Yeah,
looks
yeah.
like it's two different
Yeah,
columns.
no, yeah, this is a custom function. So yeah, I wouldn't worry too much about that. Yeah.
Good, thank you.
Okay, I think we can go ahead and get started. Let's see. So yeah, 12:40. Okay, so let's get started. I want us to take a couple of minutes to look at the there is if you go to the course materials, you should see something that says Pandas basic exercise. You click on that and it gives you a new notebook. And this is essentially just a quick exercise that consists of some of the things that we've talked about so far. I want us to take a couple of minutes to just look at this and try to see if we can attempt the questions. I think there's one major thing that I might have to do here just to. Okay, so it's data sets that diabetes. Okay, so the first line, just because I'm looking at this right now and I realized that I should have included the path to the data frame. So if you go ahead and just copy that and put that in the first portion, I just put that in the chat. Okay, so yeah, okay, so now we have our data frame. So once you copy that and put that in the first portion, and then I think you should be fine. You should be able to go just go through the remainder of the exercise.
Dr. Ebel,
Yes.
is there any way you can like maybe copy and paste that code onto the chat just so I could just copy and paste it onto
Oh
my
yeah, I did. You're not seeing it on the chat. I could repaste it.
Oh, I see it. I see here. Thank you so much.
Okay.
And when are your office hours?
So it's on Thursdays from 4 to 5. Yeah.
Thanks.
How do you copy in Zoom when you use Control-C? Doesn't work. That's interesting. Is anyone having like? Did anyone have any success copying that or?
I couldn't copy it.
Oh, okay. I think it's more specific to does not work. Huh? Okay, let's see what we can do about that. Maybe Slack probably would be best. Just give me 1 sec. Let me see where I can.
Yeah, Ebel, try to post it in Slack. I'll put it, you
Yes.
can put it under module 1. That way
Okay.
everyone knows where to find it.
All right, sounds good.
Use that link that I just posted.
Okay, there we go. Is there a module 1 created already, or is this something I should create? I'm just gonna put that here and then paste. Okay, so I just pasted that on the general, I guess, in Slack. If you have the web version, you should be able to copy. Oh, there we go. Module 1. That wasn't added. All right. Okay, it's also pasted on module 1. Got it. Thank you.
Hi, I'm getting a response that says name PD is not defined after putting that df equals PD dot read.
Okay, so do you have import pandas as PD?
Oh, no. Okay.
Okay, let's I think we'll go over this at 1 p.m. just because we have limited time. So Okay, I know it's kind of a short time to attempt all the questions, but the idea is to give you a sense of the kinds of or just going over some of the things we've talked about, more of a hands-on experience, but we are constrained by time, so. All right, let's go over this together. So basically the idea, we have a data set, and based on that data set, we are trying to attempt a couple of things. First is we import the data set, which is basically using the command pd.read CSV. So because this data set is of CSV format, so we use the pd.read CSV. If this was of another format, say JSON or Excel format, we'll probably use pd dot read maybe JSON if it's of a JSON format, or I think it's called XLS, the format for Excel sheets. But this is a CSV format, so we're saying pd dot read CSV. But before we do that, we always have to import the library. So in order for us to use the Pandas library, we have to specifically import that library to our code. And but how do we do that is by saying, using the import command, import pandas, and then we rename that using an alias. The reason why we do this is because we don't want to always say pandas.read CSV, which we can do, but it just seems more much more verbose or wordy rather, if we always have to say pandas.read CSV. So we create an alias that we can use in place of always having to repeat the word pandas. So go ahead and run this. So that imports and also creates a new data frame called df, loads the data set located in this remote location into the data frame. So we can go ahead and view the data frame. So the data frame basically contains 13 clinical features, which I've described over here. Let me see, can we just use P? Yes, you can use whatever alias you desire. This is more, I wouldn't say this is more of the unofficial alias for Pandas, but you can use P, you can use X, whatever you desire. It's just an alias. So basically it contains 13 clinical features. And we can view the data frame just by saying df.head, or we can just say df. It would give us the head and the tail, which is the first 5 rows of the head, first 5 rows and the last 5 rows, and just truncates everything in between if we just say df. Okay, so this code right here is nothing to worry about right now. It's more or less me just including a bunch of null values in there because the original data set was cleaned up already, so we didn't have null values, but I wanted us to go over the process of identifying null values and removing null values. So I included this code just to randomly add null values. So I wouldn't worry about the specifics of the code, but you go ahead, you have to run it. So it includes those null values randomly in the code, in the data set. All right, so the next question says, check for null values. How do we check for null values? So from what we discussed, you can say df.isNull, you use the isNull function, and then you get the sum of that. So what this does, it returns every column with the total number of null values. So in this case, we have a bunch of null values. Age has 16, anemia has 16, and a bunch of other null values. So, so we can identify those null values in our data set. The next is delete all null values in each row of the data frame and reset the index of each row. So first thing we delete, so how do we delete? df equals what? df dot, so we say, we could, so there are two things. We can either delete or we can replace, but in this instance, we are deleting. So we will use the drop NA command. And what is wrong with this? If I say drop NA, is this correct or no? Thoughts, comments?
No, because you're gonna get rid of everything instead of just the rows that you want to get rid of.
Right, exactly. So we need to be more specific, and this is a common mistake that we can, easily make, is just issuing a drop NA command. So we need to specify, because we are only interested in dropping the rows and not the columns as well. So we need to say axis equals rows, or you say axis equals 0. In this case, we can say axis equals rows. And you notice here, I am reassigning the new data frame that comes from this. So the way this works is it returns that data frame, so it doesn't save it. In order for us to save it, we can reassign that. So the df equals df dot drop NA axis equals rows. Another way of doing this, if you don't want to reassign, there is a command called in place. You can say in place equals true, and this way you don't have to reassign. But I typically just, it doesn't take that much to just say df equals df dot drop NA. What's the random selection? Add a seed. My null summary is different. Yes. So your null summary might be slightly different because I put in a range of values. So it uses a specified seed, but it does this in such that it's within a specified range of values. So yes, your null values will be slightly different from what I have. Okay, so now we say df equals this or that. All right, and then we do that, that runs successfully. It also does ask us to do something else. It says reset the index. We briefly talked about this, but in order to reset the index, you just say df.reset index underscore index. And then we say, let me see. Okay, so what does the reset index do? It just basically renumbers, it starts from 0 to n-1. And this is useful sometimes when you merge or you combine data frames and or you delete some values from the data frame. It doesn't automatically do the resetting. You have to explicitly reset the index. Okay, so it also asks us to display data types for each column. So display data types for each column. So we can just read summary statistics. So we can use the df.d types, or we could say df.info actually. So info, and that would give us like the name of the columns and the d types, or we can say d types. I think it's d type. Let me see. Types. Okay, and that would give us just the name of the columns and the type, the data type for each column. So you notice all of them are numeric. There is no string or date type. It's all numbers that we're dealing with. Then we are asked to display summary statistics. That is df.describe. And what does that do? It gives us a count for each column, the min, max, and so forth. Okay, now we get into more interesting stuff. It says create a new data frame called df underscore DAB blood pressure. This data frame should only consist of people within the age of 40 to 55 with diabetes and high blood pressure. Note, a value of 1 equals yes and 0 equals no. So it's just saying if it has a 1, it means that that person has, let's look at the data set. That person has high blood pressure. If it has a 0, it means that that patient doesn't have high blood pressure or diabetes. So now we're starting to use complex Boolean queries in order to get our result. So first we have to figure out like how to build the Boolean queries. So first we need to store that into a new data frame called this, and then we say, or actually let's do this first. Let's we can create a variable to store the query, and then we can say df df high blood pressure. Let's see, blood pressure. So the first says okay, so let's first start with that df age. I believe that's the so it says df age equals to is greater than people within 40 and 50. So that would be greater than or equal to 40 and df age is less than or equal to what's it called, 55. So first it says age is greater than or equal to 40 and age is less than or equal to 55. And in addition to that, it does ask us that we also want to return only patients with diabetes. So that's also another AND Boolean, because it says they all have to meet that criteria within a certain age range and must have diabetes and high blood pressure. So now we say df, what is the column name for diabetes? Oh, it's just diabetes. We say that equals 1. And let's see. And df, yes, high blood pressure equals 1 as well. Okay, so this is the Boolean condition condition statement. So let's go over it just to make sure we are correct. So if the age is greater than or equals to 40 and the age is less than or equal to 55, and the diabetes column is equal to 1 and the high blood pressure column is equal to 1. Okay, so let's run this, see. Okay, all right, now what we would do is, I'm just going to create another, is we want to filter based on that condition. So now we want to create this new column, this new data frame, and filter the result based on that condition. So now we say df, and then we pass in the condition, which is Boolean query. Let's see. Okay, so that works. I'm going to create another column and just view the values of that. Okay, so now we get a new data frame called df underscore diab underscore blood pressure. And if you notice here, if you look at the diabetes column, it's all the ones with 1s, high blood pressure, all the ones with 1s. And then what else? The age, where's the age? Okay, so age also within that range that we talked about. So I think this is good. Let's see how much, how many patients. No. Okay. So we can also do some. No. Okay. This, I think we just, the count was fine to see how many patients actually returned. Seems we have 7. Yeah. Okay. Interesting. All right. It says return the shape, blah blah blah. Shape. Okay. So in order to do this, we say this dot shape. Oh, that's interesting. So we have 7 rows and 14 columns for this. Again, yours might be slightly different just because the number of nulls might be different. So not to worry, as long as the code runs fine and you can see that the range of values are the same, then that should be fine. So here we have 7 rows, 7 records returned. Okay, another condition, it says, this condition is just saying create another data frame called platelets. This data frame should only consist of records with platelets over 2,000, that is 200,000. So this is DF platelets, and then we have DF, then we have DF, and then we say DF platelet. Platelets is platelets is greater than 2. I'm just going to copy this. Okay, so when we run this, we should get that. I'm going to see what is in there. Okay, so only the ones with the platelet count greater than 200,000. We also want to see what the shape looks like, how many records were returned. And now it says merge the, wait, did I? Okay, merge the blood pressure, new data frame for blood pressure and the DF platelet to a new data frame called DF merge. So there are a couple of things we can do here. Because it's of the same columns, the easiest approach is just concatenate. We don't necessarily need to use the merge command, because what the merge command does, it tries to merge them by commonalities. But in this instance, we're not trying to do that. We're just trying to combine the 2 data frames together. And we're not trying to do a merge by similar patient ID or in this case. So what we will do is we will just use the concatenate function. So we can call that DF merge. And then we say equals PD dot concat. And then we have the copy this, comma, platelets. Okay. And we want to merge. By default, it merges on axis equals 0 or axis row. We don't need to explicitly specify this. Okay, let's see what is in there. When we run this, it's basically a combination. It has 132 rows and 14 columns, which is a combination of the DF platelets and the the new data frame for diabetes and high blood pressure. So if you add those numbers together, you should get the same number of rows here. All right, so finally now we want to export this to a CSV file. We can say df platelets dot to CSV, and then we pass in the path that we want to export it to. I typically want to export it to the exports folder that I've created. Again, you don't have to do that. You can export it wherever you want to. But once you run this, what it does is, what is this? No directory exports. Interesting. Let's see. Okay, I think I know what that is. So I'm just going to do this. You could run this and it would create that in the same directory as your file. So it's right here. So it just exports that to the same directory as my as the file. Okay, so that's really it for that one. Yeah. Hopefully, yes. Is there any questions? Yeah.
Can you go up a little bit?
Yeah, sure.
Yeah, in here you put the blood platelet. No, up. Yeah. Why did you put the Boolean here? I know you created a Boolean query, but you put the DF before putting DF. So why this is necessary DF then Boolean query?
Are you talking about this?
A second one, second column, second row.
Oh, yes, it is very necessary because this is just the conditional statement.
Yeah, but you already make it this one, Boolean query, right? Data set.
Okay, so
then you put DF here. It's not there. In here, it's not there. So, but you put it here.
Yeah, so here, this is only the condition. This is going to evaluate the condition. And if we do this, let me show you this real quick. Run this. It's only going to give you Boolean results. But it doesn't filter it till you specify that you want the Boolean values in the data frame. So when we say take this, what the conditional statement that we've evaluated here, and return only the rows that fits that Boolean result. So only the rows that evaluate the true from this Boolean query will be returned in this when we pass in that Boolean query to the data frame. So here, this df Boolean query, what that does, instead of giving me just true, false, false for the records, it gives me a data frame that contains those results. So if I run this, it would give me a data frame, a new data frame that only evaluates to true for this condition, for these conditions. But this Boolean query only gives me true, false, 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 true, or whatever the case is for every result, every record in the data frame. I don't know if that's clear or.
Yeah, great. Yeah, thank you.
Yeah. Any question about this? Okay, if there are no questions, we will switch gears to, I know we have not so much more time, but we'll try to cover as much as we can for the visualization portion of this. All right, let's switch gears. So. Okay, so we've just a quick recap of some of the things we've talked about. We've gone through some of the powerful libraries that are used for analysis, or just the powerful libraries, in my opinion, that is used for analysis in Python. which is known as the Pandas library. And we've looked at some of the things you can do with that. There's a host of other things that you can do. I think I might want to reference that at the bottom. Where is it? Okay, so here are some of the resources on learning more about pandas and just data science in general using pandas. But this is not an exhaustive list of things. There's still like a whole bunch of things we haven't talked about. But this kind of gives you the foundation of how to import data, how to do some basic analysis on them. If you want to know more about it, some resources are at the bottom of the notebook. So with that being said, another interesting thing and very crucial, in my opinion, is once we've analyzed our data, we want to be able to present that data to people who might not have the technical expertise to understand the high level or the low level analysis of our data or just looking at numbers. So a lot of people enjoy looking at the visual presentation of data. In the next couple of minutes, we are going to glance or go over some of the ways we can visualize data using Python. So there are a couple of libraries, actually, there are a bunch of them. It's not just one. There are a couple of libraries that we can use when it comes to visualizing data in Python. One of the most popular one is what we call the Matplot Lib. Matplot Lib is, as the name entails, it's kind of similar to what you would have in MATLAB. So those of you who have experience with MATLAB, the commands are somewhat similar. They're a little bit slightly different, but for the most part, the similar commands, similar structure. We also have inbuilt visualization in each data frame. Basically what this is, it's a wrapper around Matplot Lib, but you can visualize data directly from a data frame without having to do anything extra. You can just basically generate these graphs directly from the data frame. We also have what we call Seaborn. It's another visualization tool that you can use to visualize data. Has a cleaner approach, very high level and very good visualization tool as well. And we have ggplot. And then finally, we have what we call Plotly. So these are some of the tools that can be used to visualize data in Python. So we are going to go over mostly MATLAB, Seaborn, and Plotly. Hopefully time permits. All right, so when it comes to Matplot Lib, it's pretty much similar to the types of visualization to visualization you've seen in MATLAB. But before we get into that, it's the typical visualization structure is you have a figure, you have the axis, you have a title, you have markers on the axis. So you can have the markers have ticks. So the x-axis, the y-axis. So this is kind of like the general overview of every visualization that you see well, not just Python, just in pretty much every visualization tool. So I'm not going to go into more details, but you feel free to kind of look at the image. It's pretty much self-explanatory where you have the different types of visualization. You have what we call the minor ticks, the major ticks, the labels, the x-axis, the title. Also, most of the time, if you have multiple diagrams in the visualization, you have a legend to differentiate what color is for what visualization. So this is kind of like the typical anatomy of every visualization in Python. Okay, so with the Matplot Lib, we first, just like we saw in Pandas, we first have to import the library. I want to say everybody probably should have that. If you don't have it, you can just install it. Let me see. To install it, you need to say pip install Matplot Lib, and that should install that. So I already have it, so it's yeah. I think it comes with every standard Python package. So all right. So now in order for us to use it, we need to import it first. So you basically have to have the Matplot Lib and import that into your program. So we are using the MP once again to generate a list of numbers, which you would see later on. Okay, so so with the Jupyter Notebook, we also need to specify if the image is inline. This is more specific to Jupyter Notebook. Yeah. So so for a really quick example, we want to generate an array within 0 to 100 numbers within 0 to 100 or 0 to 10, and we're going to use that as an example to plot a bunch of graphs. So we create a variable, and we basically generate an array from 0 to 10, which is like 100 array, 100 values. So we want to view that, we say X, and it gives us the values from 0 to 10. So now let's plot the sign of these values. So in order for us to plot, we need to specify a couple of things. So we create a variable called fig, and then we say plot.figure. So we need to initialize that first in order for us to generate our plots. And then we say plot.plot, and we pass in the X and the Y axis. The X axis in this case is our array of values X, and the Y axis is the sign of the values. So basically, X axis is the values that we have here, and the Y axis is the sign of those values. So let's run this. So this generates a sine curve for where our X axis is the values here, and the Y axis is the sign of each X.
Can you show the code to create X again?
To create X. So to create X is just basically np.lin space. It just gives you random numbers from 0 to 10 spaced out.
Okay, I got it. Okay.
And then
parentheses, right? Not the bracket.
No, parentheses, yeah.
Okay, I just got that wrong. Okay.
Yeah. So and this is just us showing how we can use the Matplot Lib. So we start off using some random numbers, and then we draw the sine curve of those random numbers. This is what that looks like. Let's also do the same for the cosine as well. So instead of np.sine, we do np.cosine. So it goes X values and then Y values. So this is what the cosine looks like. We can change the color of that. which we'll talk about very soon, but I just want to do that real quick. We can change that to red. So this is to draw, if we say dot plot, what that does, it gives us a line curve. So this is by default, gives us a line curve. So say, for example, we want to draw both curves, both plots in the same curve. We can do that as well. So we say, we create a variable, which we already have, plot the figure, and then we say plot the plot, and then we use the same plot variable, and then we draw the cosine as well. So this is what that looks like. This is just to indicate what kinds, if it's a solid line or if it's a dotted line. So if we take this out, it's all going to be solid lines. Yeah. So you can indicate if you want solid lines or you want dotted lines when drawing the curve. So you can have multiple curves in there. You could also have tan. Yeah. So because the tangent is a little bit larger, so it kind of truncates the curve. Okay, so once you're done with creating the graph, you can also save the graph. By saving the graph, you just need to use the command dot save figure. So run this, and it basically saves that to the location that you specified. Okay, let's see. Okay, let's go into more specific, or before we even get into that, let me talk briefly about the types of ways of creating figures. So there are two ways in which we can create figures. There is the using the Matplot Lib. There is the MATLAB style format, which is what we have been using. And the idea is basically you have to specify the, you create a variable and you specify the figure, which means to instantiate the plot, and then you can create plots on top of that. One of the problems with this approach is that every time you create a plot, it forgets about the other plot. So it's stateful in the sense that, say, for example, you create two plots and you want to modify the first plot. It's a little bit of a challenge to do that because the way this format works is it recognizes the previous state and not the, once you move to another plot, it only recognizes the current plot. Another way in which this can be done is by using the object-oriented portion or the object-oriented format, where we break the plots down into, we create a figure and we create an axis, and we could basically generate the plots using those figure and axis. So now we have an instance for figure 0 and figure 1. This way, we're able to modify each plot without having to clear the plot and recreate the plot. So in summary, what I'm trying to get at is there are two ways in which we can define plots using the Matplot Lib library. You can use the MATLAB style format, which is basically you generate a plot and then you generate another plot, or you can use the object-oriented format, which is basically you can generate multiple plots and have reference to those plots such that you're able to modify each plot without worrying about the state of the plot. All right. So let's get into more specifics of the types of plots that you can create. You can create line plots, you can create charts, and so forth. What we've seen so far is just the line plots. So with the line plots, we're going to go ahead and create more examples of that. Here, we're generating random numbers from 0 to 1,000, 1,000 random numbers from 0 to 10. And then we're calculating we're creating a plot for the sign of those numbers, like we saw earlier. We could also do, we could also create plots using changing the colors. So here we have plots, two plots that are embedded, they're created together. We can specify what the color of each plot is by using the color attribute. So here we say color equals blue and color equals red. And that basically, we can change those colors. So if you have multiple plots and you want to differentiate them, you can use the color attributes to change the colors. Okay, I'm going to skip over some of the colors just because we are 41 minutes. Okay, so we also have the, here we have the, if you want to specify what type of line it is, if it's a solid line or dotted line, you could also do that as well. We have a attribute called the line style. So when you have one dash, that means a solid line. When you have two dashes, it's a dotted line and so forth. You could also specify the size of the line. You can adjust the axis, so you can specify, say for example, the default axis is not what you want. You could also adjust those by specifying what the X limit and the Y limit is. Like in this example, the axes are adjusted. Okay. Here you can include labels as well. So instead of having just the default plots that we've seen, you can add labels to the plot. So here you add all the labels to the PLT variable. You say PLT.title adds a label, PLT.x label, PLT.y label. So it adds label to the x-axis and the y-axis, and also adds a label to the title. So there are a host of things we can do. Just because of time, I'm going to skip over just some of these things. You can kind of look them over on your own. A lot of the code is on here. All you just have to do is run them. But there are a host of things that you can do to a graph. You can add the grids. You can add labels. You can change the line size, the line color, the line width as well. Okay, so now let's look at the different types of graphs that you can have. You can also specify scatter plots. So if you don't want it to just be a line, you can specify if you want it to be a scatter plot. The key thing here is by specifying the O parameter, and that converts it from a line to a scatter plot. Like you can see here, it's the same plot X, Y, but the difference here is just this parameter that specifies it's a scatter plot. So there are different types of markers you can have, and you can look at some of them here. You have the O, you have the dot, and they all specify different sizes and shapes of plots. So it's not just the default dotted scatter plots. You can have X's, you can have triangles, different colors, different schemes. All right, so moving on from just line graphs and scatter, you could also create graphs directly from the data frame. But before we get into that, let's talk about like bar graphs. So with the bar graph, The idea is that you're creating, instead of a scatter or line graph, you're creating a bar graph. You can use the same instance of the plot, but this time you're specifying that you want to create a bar graph. So instead of saying dot plot, you just say dot bar. And then specify what your X and your Y is. And this way you're able to create a bar graph, still using the same Matplot Lib instance. Okay, so you could also customize the bar graphs. You can include colors, pretty much the same as you would with the line graphs. Here you say dot bar, and you include the X and the Y axis. You include the label, and also include a color for each graph, for each bar graph, a bar chart. You could do the same with histograms as well. So the difference here is instead of saying dot bar, you say dot hist. You can change the color of the histogram. So instead of having the default dark blue, you can reduce the alpha of that and it becomes lighter. So those are some of the fancy things you can do. You could also include no edge color. So if you pay close attention to this, you see there's a white edge color here. You can remove that by saying edge color equals none as well. So here we have a multiple histograms overlaid between each other. Okay, so that is using the Matplot Lib. You can also visualize directly from the Pandas data frame. So you don't have to call any special function for that. So in this example, we have our data frame and we want to create a line plot using just the data frame. So you can directly just do that by saying the data frame or specific column in the data frame dot plot, and that would give you direct access to Matplotlib from the data frame. So here we're saying we just only want the A portion, the A column. We want to draw a line graph from the A column of the data frame, and then we plot that. We specify the size, we specify the width, and then we specify the style. And also we include like X label and Y label and also the title. So when we run this, let me run this first. And run this, it gives us just the line graph of the column A. So you can directly visualize your data from the data frame without actually having to call any additional library. You can do the same using a scatter plot. So the key here is the data frame dot plot dot scatter, and it's pretty much the same. You specify what the X and the Y is. In this case, X is A and Y is B. So X is column A and Y is column B. And then you can specify the width and so forth. You could have multiple embedded inside of the same plot. So in this instance, we have multiple graphs actually. We have A versus B, C versus D, A versus C. So the idea here is I'm trying to show that we can have multiple plots embedded inside of the same figure. And you can do this directly from the data frame. You could also draw a bar chart directly from the data frame. Here we have just the column A. We want to draw the first 10 records in the column A. We plot the bar chart. So here we specify what kind. It's a bar, horizontal bar. We have the legend, and when we run this, it gives us a horizontal bar chart. You could do a stacked, I guess, a stacked bar chart. Pretty much similar. Here we say kind is bar, and we say stacked equals true. So this is another type of bar chart, but you notice that the values are stacked amongst each other. So it gives us like different stacked values. You could also draw a pie chart as well, directly from the data frame without calling any other additional library. Here we have our data frame, and we want to draw a pie chart. We just change the kind to a pie, and we can directly draw the pie chart. So you can actually, you don't necessarily need to use Matplot Lib. Directly from the data frame, you can basically call Matplot Lib. They've written functions that makes it a lot easier. All you just need to do is say the data frame dot plot, and you specify what type of chart you're trying to draw. If it's a bar chart, a histogram, a pie chart, you can directly do that from the data frame. Okay, I want to say, let me talk briefly about this and we'll conclude here. So Plotly is another type of library that we use to visualize data. So Plotly is similar, but it's more of a web style graphical visualization. It allows us to create these custom visualization that we can basically use on the web. It's easy to port this to the web pages and so forth. But it does allow for a nice visualization in Python as well. So with Plotly, you can draw all of these visualization also that we've shown using Plotly. So in order to use Plotly, this is a library, so we need to also import that. So go ahead and run pip install Plotly, and you should be able to import that or download Plotly. So I have a data frame that I'm importing. It's called the Iris data frame. It's a very popular one. It contains the width and the specification of different iris plants. And we're just going to use this for demonstration to demonstrate the types of visualization we can perform on this. So let's go ahead and see how we can draw a line graph using Plotly. So the code to draw a line graph is to specify px.line, and this is, you already imported the library after downloading it. So you've imported that into your program, and all we're doing is we're using that to draw a line graph. So our x-axis is the species in the data frame right here, and our y is the petal width. Where is that? Petal width right here. And then we have our title, which is the Plotly graph. So go ahead and run that. It takes a little bit of time. And we have the visual graph. So you notice here, this is a little bit more cooler because you can take a PNG image, which I just downloaded. Let's see. You can see the PNG image, which I just downloaded. You can directly download that using Plotly. I think you could also download a PDF of it. But there are a bunch of things you can do that is nice when you use the Plotly library. You could also draw a bar chart using Plotly as well. So here the X is the sepal width and the Y is the sepal length. So this is what that will look like using Plotly library. Likewise, you can draw a histogram as well. So basically the same kinds of visualization you can do using Matplot Lib. You can perform them using a different library called Plotly. You could also have a scatter plot and a pie chart. All right. I want to leave some time for questions because I know we some of you might have questions. We only have 5 minutes. I apologize, but unfortunately, we're not able to cover everything. The materials are there for you to look at. I will upload the solutions to all of the exercises, so you can kind of go over them on your own. And if you have any questions about that, please feel free to reach out to me. I'll post my email on the chat, and also I have office hours on Thursdays from 4 to 5. If you want to, you can also reach out via email. We could try to work some now if that date doesn't work for you, if the day doesn't work for you. But yes, so I will open the floor for questions.
Any question for Dr. Nwafu?
I have just one question regarding the Matplot Lib figures. So the original figures show all these grid lines, but when we run that, the grid line disappears. So how the grid lines will be will appear here?
You need to. I think you need to specify the grid. There is a function to specify grid, but by default it just comes it goes off. Yeah, but there's a function that you need to specify in order to specify grid. I think it's but we can talk about that offline now. Yeah,
sure. Can you show one more time how to download this figure to your local drive?
Oh, okay. It's right here. It says plt.savefig. And then you put the location. It should save it in wherever location you put that. So I have one here. I have some that I ran before. Let's see. Yeah, so once you put the let's see, PLT that. Yeah, .savefig should save that. Yeah.
So it's a syntax only for PLT or for all of the figures you can use that?
When you say for all of the figures,
like Seaborn or like
no, no, I think they have their own different syntax.
To save it.
But this is for Matplot Lib, yeah. Yeah, this is specific for Matplot Lib, yeah.
All right, perfect. So it's only this PNG you can save.
No, you can save it in PDF as well, or JPEG.
Yeah, or TIFF, TIF.
Huh?
Can you save to TIFF, TIF?
TIF. I'm not sure. I've never saved in that format, but I mean, I'm sure you could save it in other format, not just JPEG, not just PNG though.
So you just use the save fig. It's the same command, but just change the surface. Okay. Thank you.
Yeah, any further questions?
Yeah, and please be reminded that we do have office hours. I think we have one today, as Dr. Ebel mentioned. There'll be one on Saturday. Oh, on Thursday.
Thursday,
sorry.
yes.
On Thursday. Yeah, we do have one tomorrow from I think from 5 to 7. And check the TA office hours channel. Stacy will post, or I will post. I'll post something in there tonight. If you don't get it, please just send us a reminder. But there will be something posted in the TA channel, and there will also be something posted in the general. Stacy normally posted on the in the general channel, and then I copy it over to the TA channel. And then send us an email if, let's say, by the morning you don't see it. shoot me a mail.
Yeah,
Or
so
chat.
William is talking about Slack. You have to go to Slack to get those information he's talking about.
Yeah.
Yeah, so if there are no further questions, then thank you so much for coming, and then thank Dr. Wafu for an excellent presentation over the past 2 days. So we'll meet again next week for classification models at same time at Thursday and Friday. So thank you again for coming, and then we'll see you next week.
Thank
Thank
you.
Okay, thank you. Yeah, thanks. Bye-bye.